Alright, so 5 is about roots and zeros. And we're going to use the fundamental theorem of algebra to determine the type of roots and zeros for polynomial equations and determine the number of types of roots of polynomial equations and find the zeros. So the fundamental theorem of algebra is something I've mentioned before. The fundamental theorem tells us that every polynomial function of degree n, okay, so n is the variable, has exactly n roots, okay, or n zeros. Those two words are interchangeable. Okay, so if the degree is n, there are n roots or n zeros. And this is going to include multiplicities as well as real and imaginary zeros. Okay, so I've mentioned multiplicities before. A multiplicity is when a zero occurs more than once. So what this means is if you have a quadratic function, remember, a quadratic, the highest exponent or the highest term is x squared. So how many roots is that going to have? 2. Okay, every cubic function, which is x cubed, is going to have 3 roots. Every quartic is going to have 4 roots, and then so on and so forth. Do you guys remember what x to the 5th is called? Yeah. Quintic. Yep, quintic. I always remember, like if there are 5 babies born at one time, they're called quints or quintuplets. Because in the 80s, there was a toy called Quintuplet Surprise, where you'd open up this puppy and yeah, with Velcro. It was Velcro together. And you'd open up and you'd count how many puppies. Yeah, quintuplets. I get 5 little puppies. It's the best day of my life. Yeah, they don't make toys like they used to. Okay, so a multiplicity, what is a multiple root? It's a root that appears more than once. Okay, so a root that appears more than once. So we've talked about this a little bit when we've had some multiplicities. I've mentioned them to you. We're going to look at a couple of those examples together. So one example would be when you're solving 3x cubed equals 0. Okay, so when you're solving this, you would divide both sides by 3. And then remember, when you are solving something like this, you got to show me that you're taking the cube root of both sides. Okay, many of you did a nice job of that on the last quiz. Okay, but some of us are neglecting that step, and we got to make sure we write that down. So this is x equals 0. So when you take the cube root, this is a multiplicity. So we're going to say with a multiplicity of 3, which means that it occurs 3 times. And there are ways to pick this out on the graph that I will show you and we will talk about. Okay, so this is an example where 0 has a multiplicity of 3, and that means it counts 3 times for your zeros. Okay, another situation where you can have a multiplicity might be something like this, where you have x squared plus 8x plus 16 equals 0, and you're trying to solve for x. So it's a trinomial. We're going to factor this. It's a perfect square trinomial. So you have x and x, what multiplies to 16 but adds to 8, 4 and 4. So according to the zero product property, I could just set each one of these equal to 0 and solve. Well, in both cases, I would get -4. Okay, so because -4 occurs twice, we would say x equals -4 with a, and I'm going to let you abbreviate multiplicity. You can just say mult of 2. Okay, so because it happened twice, we say -4 has a multiplicity of 2. Okay. So the multiplicity of a root is the number of times the root is a 0 or a factor. Okay, the number of times the root is a 0 or a factor. All right, so today we're going to be solving equations, and we're going to state the number and type of roots in example 1. So the number is just going to be how many there are. The type of roots, you're going to say whether they're real or imaginary. Okay, and I'm fine if you use the real symbol for that. Okay, and the other one is imaginary. So they're real or imaginary roots. Okay, so we're going to start with x squared minus 8x plus 25 equals 0. So keep in mind, according to the fundamental theorem of algebra, if this is a quadratic, the degree is 2, so that means you have 2 zeros. Okay, so that's all we have to find here. If it is a quadratic, it's a quadratic trinomial, we're either going to factor, or if it's unfactorable, what can we use to solve? Yeah, the quadratic formula. Okay, so two numbers that multiply to a positive 25 and add to negative 8 doesn't exist. The lowest factors are 5 and 5, and if we add those together, you get negative 10. So there's no way that we can factor it. So we're going to use the quadratic formula. So I like to write out my A, my B, and my C. That helps me when I'm plugging it into the quadratic. So I have x equals the opposite of B plus or minus the square root of B squared, so 64 minus 4AC divided by 2A. Okay, so I want you to see if you can simplify that down. So that is something that we've done before. Okay, so see if you can simplify that all the way. Okay, so when you multiply, under your radical, we know 4 times 25 is 100. Okay, so if we do 64 minus 100, we'll get negative 36. And anytime there's a negative, what do we have to make sure goes with it? The I. So it's 8 plus or minus 6I divided by 2 divided by 2. We can't divide anything by 2 here, okay, with the radical. Okay, but we can simplify. So we have 4 plus or minus 3I. Okay, so this is solving the equation, and now we just have to state the type of roots and the number of roots. So you have 2 roots within here. You have 4 plus 3I and 4 minus 3I. So you have 2 imaginary roots. Okay, so you have your solution, and then you have to state the number and the type. Okay, and then for the next one, we have x to the 5th minus x cubed minus 6x equals 0. So in part A, we were able to use the quadratic formula because we have a quadratic equation, but we don't have a quadratic equation for part B. So we're going to have to come up with another method. So what do you guys see that we can do here? Yeah, take out your GCF. And because the degree of this is 5, we should be finding 5 zeros. Okay, so we're going to keep that in mind. So yes, the first thing we're going to do is we're going to factor out the GCF. So we're going to take out x. So go ahead and do that. Okay, and then once you take out your GCF, we have another trinomial. Again, it's not a quadratic, so we can't use the quadratic formula. So we're going to try to factor that down as well. If we have x to the 4th, we can split it into x squared and x squared. We're looking for two numbers that multiply to a negative, 6, add to a negative 1. So you have to have a positive and a negative. What are our numbers going to be? Good. So 2 has to be positive, 3 has to be negative. And then from there, you can use the zero product property. Okay, so we know x is equal to 0, so there's no solving to do there. X squared plus 2 equals 0, so we're going to solve that. And x squared minus 3 equals 0, so we're going to solve that. Okay, so again, when you're writing out your work, it's fine if you move over the 2 to the negative, but then you need to show that you're taking the square root. That's how you're getting your final answer. Okay, because it's a negative, that I is going to come out. So you have plus or minus I root 2. Okay, and then for the last one, you have x squared equals 3. Again, we're showing that we're taking the square root. That's how we're getting this last set of zeros. And remember, you should have 5 zeros total. Okay, so when you're solving the equation, your zeros are 0, plus or minus I root 2, and plus or minus root 3. Now we have to state the number and the type, and just whether they're real or imaginary. Okay, so how many imaginary ones do we have? 2. So 2 imaginary, because we have the I root 2 and negative I root 2, and that means root 3 and negative root 3, those aren't imaginary, they're real. So we have 3 real roots. Plus root 3, minus root 3, and 0. Those are all real. Okay, so if they don't have an I with them, they are going to be real roots. Okay, so we have 2 root theorems. Okay, the irrational root theorem and the complex conjugate theorem. They are very similar to each other. Okay, they just are going to tell you about different types of roots that have to be zeros. So when you have an irrational root, there is a square root in there. So if you have a plus b root c, if that's a root of the polynomial, then its conjugate, a minus b root c, that is also a root. Okay, and those are some complex examples. It's the same thing that we have here. If positive root 3 is a root, so is negative root 3. Okay, and it follows the same type of logic. So if you have 2 plus root 3, if that is a root, if 2 plus root 3 is a root, so is, we're going to fill that in. Okay, so if you have 2 plus root 3, the conjugate is 2 minus root 3. So that would also be a root. Okay, if you have negative 1 minus 2 root 5, if that is a root, Okay, its conjugate also has to be a root. Now look here, see how this is A and this is A? The A doesn't change signs. So if it starts with -1, it's still going to start with -1. The only thing that changes sign is what's in front of the radical. So if this is a -2 root 5, it's going to be a +2 root 5. Okay, those always come in pairs because when you take the square root, you have a plus or a minus. And that's why it works for the complex conjugates too, because those come from square roots. So if you have a plus bi is a root, which remember is our complex form, then its complex conjugate, a minus bi, is also a root. Okay, so if -2 plus I is a root, so is, and then see if you can fill that in. Okay, so if -2 plus I is a root, so is -2 minus I. You got it. Okay, so if you have 1 minus 3I, can you guys write the complex conjugate? What else has to be a root? Yep, 1 plus 3I. Okay, we're going to use this more tomorrow, this complex conjugates theorem. Okay, but you're going to see it in answers like this. If 4 plus 3I is a root, so is 4 minus 3I. If I root 2 is a root, so is negative I root 2. Okay, so that's where those come from. All right, so now what we're going to do is we're going to find all zeros. So the first thing that we're going to do when we're finding all zeros is I'm going to let you guys use your graphing calculator to help you. You don't have to use a graphing calculator with this. You could do some guessing and checking. It would take you a little bit longer, but just in case you find yourself without a graphing calculator, you could do that. Or if you're doing this at home and you don't have a graphing calculator, you can also use Desmos, the Desmos app, to find your x-intercepts. Okay, and then once you find your x-intercepts, we're going to use synthetic substitution to verify the roots and create what's called the depressed polynomial. Okay, it's not sad, it's just 1 degree less than the other one. Okay, 1 degree less. Okay, so what you want to do is you want to keep doing synthetic substitution until you get a quadratic. And that's because you can solve quadratic functions using the quadratic formula. Okay, so we're going to set it equal to 0 and we're going to solve. Okay, so when you solve, you are going to use the quadratic formula, or in some rare cases you can factor, but factoring is not always going to work. Okay, but you can always use your quadratic formula. Okay, so solve the quadratic function by setting it equal to 0, and then you use the quadratic formula, or you can factor. Okay, and then we're going to identify all the roots and the zeros. So keep in mind, we know that the number of roots is equal to the degree, and the degree is always the highest exponent. So whatever your highest exponent is, that's how many zeros that you should have. Okay, now on your homework, for the ones in example 3, it's going to ask you to sketch a graph. You don't have to do the sketching. Okay, we're going to use the graph to find your x-intercepts, but you don't have to sketch it. All I want to see are these 4 steps here, and we're going to go over them together. So feel free to use your notes so you know what you have to include to get full credit on your homework. Okay, so we're going to find all the zeros of each function, and it says using synthetic substitution. So we are going to have to verify with synthetic substitution here. So the first one is a cubic function. It's x cubed minus 2x squared minus 2x minus 3 equals 0. So right away when I see this, I'm thinking to myself, okay, I should have 3 zeros total because that's my highest exponent. So that's definitely something we want to keep in mind. Okay, so the first step says to find the x-intercepts. So that's what we're going to do. You're going to find your x-intercepts, and you can either use the graph or the table on your graphing calculator. Okay, so on your graphing calculator, I want you to y equals. We have something in there, go ahead and clear it out. We're going to go x to the third minus 2x squared minus 2x minus 3. Okay, and then just in case your window is not the standard window, we'll go to Zoom Standard to make sure we have that 10 by 10 grid. And then I can see my x-intercept pretty clearly here. I can see it crosses at 3. I could also verify that in the table by looking for what? What else? Where the y is 0. Okay, so your y is 0 at 3, so your x-intercept is 3. Okay, so when you're doing that as your first step, what you're finding are where your real zeros are. They're actually real zeros and they're rational zeros, which means they can be written as an integer or a fraction of integers. So once you find that real zero, you are going to verify it in step 2 with synthetic substitution or synthetic division. They are the same. So we're going to use synthetic division with the x-intercept that you found. Okay? So we found that it was 3. So when I'm setting up my synthetic division, I'm going to put 3 on the outside. Okay, and then I'm going to line up my coefficients. So I have 1, negative 2, negative 2, negative 3. The same rules of synthetic division apply. We're using the coefficients. If there was a gap, I would use a placeholder. Okay, so now I'm going to do synthetic division. Now, I've already seen that this is an x-intercept. So when I'm doing this, I should end up with a remainder of what? 0, okay, because it is going to be a 0. So 1 times 3 is 3. Add straight down to get 1. Multiply. Add straight down. And yay, I did this right because that is my remainder. Okay, this is verifying that 3 is a 0. So this tells me here 3 is a 0. So I've already found one of the 3. Okay, now what this produced was a quadratic. This is my number, my x, and my x squared. And that's going to lead me to my third step, which is to solve the quadratic function. Okay, so we're going to solve the quadratic. So we have 1x squared, or just x squared, plus 1x, or x, plus 1 equal to 0. And then we're either going to solve by factoring or the quadratic formula. Well, there's no two numbers that multiply to 1 and add to 1, so we're going to use the quadratic formula. So again, I like to write out the values of a, b, and c. This helps me So make sure I don't make any small mistakes when I'm plugging it into the quadratic formula. So I do the opposite of b, plus or minus square root b squared, which is 1, minus 4ac divided by 2a. So I can see inside it's 1 minus 4, which is going to be negative 3. Okay, and so I'm going to simplify this. I have negative 1/2 plus or minus I root 3 over 2. Okay, and remember you can either write it like that or put your I on the side. All right, so then your zeros, which is step 4, are going to be these two that you have here, and then what's the third one? 3. Okay, so you have 1, 2, 3 zeros. You have negative 1/2 plus I root 3 over 2, and negative 1/2 minus I root 3 over 2, and 3. So that's where you get all 3 of your zeros from. Okay, so with that one, I tried to write out all the steps for you. We're going to do the next one together too. I'm going to let you go ahead on some parts. So for b, you have x to the 4th minus 3x cubed plus 5x squared minus 27x minus 36 equals 0. Okay, so I want you to plug that into your graphing calculator, and I want you to find the x-intercepts. So this is x to the 4th, so we should be finding 4 zeros total. This is a quartic, so it is going to be a little bit different than part A. Right, so what I want you to do is find your x-intercepts. So I'm giving you time right now to plug that into your x equals and find them either on the graph or on your table. Okay, and you should find more than one. You can verify your graph with mine, make sure they look the same. And if you want, you can even verify with the table because your y value should always be 0. So negative 1 and 4 are your x-intercepts. Okay, so when you go to step 2, where you're verifying with the synthetic division, you can choose which one of those you want to use. It honestly does not matter. I'm going to use negative 1 first since that comes first. And I'm still going to line up my coefficients. I want to give myself enough room to make sure I don't make any mistakes when I'm doing my synthetic division. Okay, so I'm going to use the negative 1 first. Okay, and then once you get 0, that confirms that negative 1 is a 0. Your remainder is 0. Then negative 1 is a 0. Okay, but if you look here, this would be a number, an x squared, and an x cubed. So this is not a quadratic function. This is a cubic function. So in order to get the quadratic, what we do is we use these as coefficients. Okay, so we're going to use the 1, negative 4, 9, and negative 36 as coefficients. To get a quadratic polynomial. because once we have that, we can solve. Okay, so we're going to do synthetic division again, but with 1, -4, 9, and -36. Okay, so remember how we had two x-intercepts? We already used the -1, so we can't use it again. It will only work again if you have a multiplicity. Okay, so we're going to use the 4. Okay, and I'll give you a moment to do your synthetic division on your own. Okay, so 1 times 4 is 1 times 4 is 4. So that's going to be 0. 0 times 4 is 0. 9, 36. Okay, how do we do? Very good. All right, so what this tells you is that 4 is a 0. So we have found 2 of the 4 zeros. Okay, so this is your number, this is your x, this is your x squared. So that's going to take us to step 3. Step 3 is solving the quadratic. So if you have x squared, 1x squared plus 9 equals 0, you're going to solve that for x. Now you don't have to use the quadratic formula for this one. You can just move over the 9 by subtracting. Okay, so then you have x squared equals -9. You can take the square root of both sides. Do you guys know what the square root of -9 is? Close. Plus or minus, yeah. Okay, so plus or minus 3x. It's like the Simon Says, where you didn't say Simon Says. You didn't say the plus or minus. Okay, so for 4, your zeros, you should have 4 total. And you have -1, 4, and then you can write the plus or minus, you can write those together. That's perfectly fine. Okay, so those are your 4 zeros. Okay, now this one was actually special. I don't know if you guys noticed this or not. This happens sometimes, it doesn't happen always, but the cubic function that we had in step 2 is factorable. So if you were to notice something like that on your homework, you could solve it by factoring. If you have x cubed minus 4x squared plus 9x minus 36, you can factor this using what technique if you have 4 terms? Yeah, the grouping. Yes, yeah, where you chunk them together, right? So you could take out the x squared here and get x minus 4. You could take out the 9 here and get x minus 4. Again, I just want to stress to you that this is only happens sometimes. So it happens with this one. It does not happen with all of them. But you would get x squared plus 9 times x minus 4, and then you could solve. So what we did is we used synthetic division to see that 4 was a 0. You could also get it from factoring here. Okay, and that would be fine. But remember, you can only use grouping when these two are the same, and if you try that with some other cubic functions, it's not always going to work out. Okay? All right, now this one we had x cubed, and how many times did we do synthetic division? Once. When this one was x to the 4th, and how many times do we have synthetic division? Twice. So let's talk about why that is. When you're doing synthetic division, you're taking this power of x cubed and you're dividing it by a power of just x, because this is like x minus 3. So when you divide x cubed by x, you get x squared, which is what we want, a quadratic. So if you have something like x to the 4th, if you just divide it by x, you get x cubed. That's not enough. But if you divide it by x again, that's when you get the x squared. Okay, so in the next one, when we have x to the 5th, how many times are we going to have to divide it? We're going to have to divide it 3 times in order to get a quadratic function. Okay, So we're going to talk about some strategies when you have a quintic polynomial. So we have x to the 5th minus 6x to the 4th plus 8x cubed plus 8x squared minus 16x equals 0. Okay, so what's nice is we already know that we're trying to find 5 zeros. We want 5 solutions. So our first step is to look at the x-intercepts. Now, because we're doing synthetic division 3 times, it would be really nice if we had 3 x-intercepts. Let's see if we get that. I'm also going to show you how you can just go to second insert, and you can insert x to the 5th, insert the minus 6x to the 4th, and then plus 8x cubed plus 8x squared. Some of you are like, no, it might just be easier for me to do that. That's fine too. And then delete, delete, delete. Okay, so when you're graphing this, again, you are looking for those real zeros, and they are going to cross at whole numbers. This one doesn't really cross at the whole number. This is a really good example of where you should look at the table. So we're going to look at the table for this one, and I want you to write down what the zeros are according to your table. Okay, so I can see 2 of them on my table. I can see one at 0 and one at 2. All right, so when we go to step 2, when we set up our synthetic division, remember that there can't be any gaps, so you have x to the 5th, x to the 4th, x cubed, x squared, the x, and then you have to have the constant. If you're missing the constant, you got to put the 0 in there. So you have to make sure that that one ends in a 0. Okay, and again, it does not matter the order that you do this in. So whether you do 0 first or whether you do 2 first, it does not matter. Either one should give you a remainder of 0. So I'm going to do 0 first. 1 times 0 is 0. Add straight down. 0, add straight down. 0, add straight down. 0, add straight down. 0, 0. Okay, so this is going to give me a quartic. Oh, I'm also going to show you how you can do like a little, I call it a hook move. So instead of rewriting those all again, if you want, you can just do synthetic division here. You just don't include the remainder. You can write it again if you want to. I just know sometimes we look for ways to not have to rewrite things out. Okay, so now I'm going to use my 2. So I'm going to drop down the 1, multiply to get 2, add to get -4, multiply to get -8, then I get 0, gives me 8. Yay! Now I have a cubic. So I've already found 2 of my zeros, 0 and 2. Okay, I want to do synthetic division again. This is an example where if you tried to factor, this would be x cubed minus 4x squared plus 8. Okay, you would not be able to factor that. Okay, because you can't split this up into like the x squared and the x. So we do need another 0 in order to use the quadratic formula. So remember at the beginning, we talked about there are multiplicities. And when there are multiplicities, it means a 0 happens more than once. And I'm going to give you a hint of how to find these on the graph. So on your graph, if there is a multiplicity, it doesn't go straight through the x-axis. So see at 0, this goes straight through. But look what happens at 2. Does this line go straight through 2? Nope, it actually touches it and then goes back down. When that happens, there is a multiplicity. Okay, so you could guess and check to see which one of them had a multiplicity. Okay, but I'm giving you a little hint to tell you when you're looking at the graph, if it doesn't go straight through, check that one for a multiplicity. Okay, so when that happens, we're going to see if there's a multiplicity. Okay, if there is a multiplicity, then you're going to be able to do this again. Okay, so if you tried 0, it would not work. You would not get 0 as your remainder. Okay, and so you'd know that it was not a 0. But if we tried 2, which is where we said we have that touchback, let's see if it's going to be a multiplicity. Okay, so you know that it works because what do we get as our remainder? Yep. And now we have the quadratic. Okay, so x equals 2 occurs twice. Okay, that's what that means. Okay, so we are going to go to step 3, but for step 4, when you're writing out your zeros, we've already found some. Let's write those down. So we already found 0 happens, and then we say 2 with a multiplicity of, it occurs twice, so it's 2. So we have 1, 2, 3. We have to find 2 more. Okay, so we're going to set the quadratic equal to 0. And you're going to use the quadratic formula to solve. Okay, so I'm going to give you a couple moments now so that you can do your quadratic formula. Okay, let's see if we can simplify it all the way down. Let's do our quadratic formula. I see some good simplifying. Okay, so when you do the opposite of b, plus or minus b squared minus 4ac, one of the main reasons I like writing that out is so that I can see whether I have to add those together, because a negative times a negative is going to be a positive. So underneath the radical, you get root 20, but we can't leave it like that. And we can't divide here. Why? Yes, one is under the radical, one is not. So we're going to simplify and yep, I'm going to make it 2 root 5, because this is like the square root of 4 times the square root of 5, which is 2 root 5. Okay, and now I can simplify. So 2 divided by 2 is 1. 2 divided by 2, those are going to cancel, and you'll be left with root 5. Okay, so you have 0, 2 with a multiplicity of 2, 1 plus root 5, and 1 minus root 5. Okay, and those are all of your zeros. Okay, and this is something that you're going to use next year as well.